Hello and welcome to the next episode of Klingberg Wing Mark II Development. I'm Raul Klingberg, your host. Today I've been outside on a warm and sunny California day making some graphite tubing for attaching the wingtips on to the middle section of the wing. What you see here is I've produced two pieces of tubing. I used this fiberglass pull-truded tube as a mandrel to form these tubes. And in the following video, I'm going to take you through all the steps that I used to make these parts. But let me show you what they're for. I'll take one of these off of here. Actually, I'll take them both off. First of all, you'll notice that they are longer on one end than the other end. If I flip one over, you'll see that they're longer that way. This tape that you see here on these tubes indicates the cut line, or the center of for alignment of the tube in the wing. The long end goes inboard, the short end goes outboard. Now these two pieces of tubing weigh 1.55 ounces each, so that's very light. It's excellent. They should be just perfect for their application. Now, where they're going to go, if you can see this, I'm going to try to hold this up. Hopefully you can see this. This is the rib outline. You'll see a red, perhaps you'll see the red outline of the rib, and then you see a black outline of the winglet mounting base. So here's the winglet here. You see the nose of the winglet here, and these two lines here represent a box that's going to go in between the wingtip and the middle section of the wing. This box, this winglet base box or mounting box, will stay attached to the winglet, and when the wing is assembled, this box will be slipped on to the wingtip, and then the whole unit will be slipped on to the middle section of the wing. And these tubes that I made today will serve as guides and pin alignment at the leading edge, and these help transfer loads. So let me move the camera for you so you can get a better view, top view of what I'm talking about. Stand by. So here you are. You're looking at the leading edge of the wing here. Here's the wingtip. It's the middle section of the wing. Here's the winglet itself. Don't know if that's in frame or out, but the winglet's back here. Here's what I was showing you earlier, the rib outline and the outline of the winglet mounting box. And these tubes are going to go right in the leading edge of the D tube front of the wing. And these tubes, when they're bonded in there, will serve to align the leading edge of the wing, and will also transfer the torsional loads from this D tube to this D tube. And this tube is actually going to be cut into three parts. Short section goes outboard. There will be a short section right here, which is cut on an angle to match the sweep of the wing, and this short piece of tube will be bonded inside of this winglet mounting box, right in this location. And then this portion of the tube that I cut off here will be bonded inside this D tube, and this portion of the tube gets bonded inside this D tube. So use your imagination here for a bit. Suppose that we have this. The mandrel itself, I'm going to cut off a piece. It'll be bonded inside here, inside the outboard portion of the tube. It'll be bonded in out here, and there'll be a piece that extends this way. So you have to kind of imagine that. And so this will be essentially in the wing. Let me spin this around. This will be in the wing like this here, and this will be sticking out slightly. And when the wingtip is slipped on, this is going to come through like this, and it's going to go inside that tube just like that. So it's this joiner here will actually go through the little piece of tubing that's inside the winglet mounting box and right into this tube that's inside this D tube. So that's how I'm going to transfer the torsional loads from this D tube to this D tube. All very lightweight, easy to make, and cost effective. The only potential drawback is that these pultruded fiberglass tubes are very good in tension and in shear, but in compression they have a tendency to crush too easily. So in the portion that extends beyond the winglet, this portion of it, it'll have a wood dowel bonded inside, and the wood dowel will provide all the compressive strength that's needed to prevent crushing of the tube. The loads that are carried this way are mostly shear loads of one of the D tubes trying to do this in torque, and it puts this fitting in shear, which the pultruded fiberglass will withstand quite well. There will be some bending loads up and down as the wing is lifting. There'll be some of those also, and that's where you could get into a little bit of crushing load on this, and just a little piece of poplar wood on the inside will take care of that. So please watch the rest of the video and see how these tubes are made. And I hope you come back and see all my other videos as they come out. If you're new to me, please look at the other ones. You'll see further information on how this tubing is made. Thanks for coming, and here we go with the production of the tubing. Today I'm making the leading edge tube for the wingtips, where the wingtip joins the middle section of the wing. This is right where the winglet's installed. This piece of tubing that I'm going to make is actually for both sides of the wing, and it carries the torsional loads from the D tube past the winglet and over to the next D tube. So it's going to end up in 3 sections, and it's going to have a little joiner piece, alignment pin involved with it. So what I have set up here so far, you see I have the braided carbon fiber sleeve already on my mandrel. What I'm using for a mandrel is a piece of pultruded fiberglass tubing, and I hope you can see it here. I've overwrapped that tubing with some 2 or 3 mil mylar polyester. Polyester is the cheaper version, and if you can see it here, I have done a spiral wrap on here. In the past you've seen me do a straight roll wrap, and they have to tape off the edge. It was quite a bit of work. The spiral wrap, believe it or not, 2 or 3 pieces of tape, zing, 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 and you're done. Much faster, much easier, and it's easier to remove. Because when the tubing is pulled off the mandrel, I can grab a hold of the polyester on the end and begin to untwist it opposite of the spiral, and it just comes undone on the inside of the tube. Much easier. So I'm pushing this back here, and I'm going to treat the polyester release layer with some mold release. This is a petroleum-based mold release. You spray it on, give it a little bit of time to dry, and you're good to go. I'm going to do this end, and we're going to take one of those little flash breaks while this dries a little bit, while the volatiles dry off on that, and then I'll slide the sleeve back the other way, and I'll spray the other end. Okay, as you can see, I've pulled the carbon sleeve up tight to the mandrel. I've treated the entire plastic wrap, polyester wrap on the tube with mold release. And right now I'm going to place a little bit of masking tape at the end of this. You'll notice that I've trimmed the ends of the carbon fiber sleeve so that they don't extend past the plastic, because we don't want to be gluing the tube to the mandrel. So to help hold it in place, I'm just put a little piece of tape around there. That keeps the ends from fraying during the layout process also. Yep. Get the roof of the patio there a little bit. Let's make sure these are, the whole thing slipped a little. There we go. Got it back. Okay. So let's make sure we don't go past the end of the plastic there. Right there. Last thing we want to do is glue this darn thing to the tube. Let's double check this one more time, make sure it's pulled tight. Looks like we might have a little bit of extra at the end. I do indeed. So let's just trim that off. Because I'm making this tube significantly extra long so that there's plenty of material to trim off at the end. Get a nice clean end. We don't want to use any of this end of the braided sleeve in the final piece of tubing.
because it's all frayed, has no structural quality to it. There we go, we got that trimmed back. Put the piece of tape around it. There we go. Now I'm not going to bore you with the glue mixing process. We'll cut that part out. And in the meantime, we'll just keep this camera running. Now, before I actually begin to wet this material out, I wanted to show you the doubler. You notice that the doubler for the center piece of tubing that goes in the winglet mount and the ends of the tubes that fit into it have to be thicker in order to take the loads and transfer them from D tube to D tube. So the total piece that I need is 2 feet long. Let's see, 2 feet long. I got to have it from here to here. Okay. So the center of this, I want to have a portion of this. Let's see, what do I got set up here? I got about 1, 2, 3, 4, 5 inches on each end. That will be one layer, and then we're going to have a doubler on here that tapers down and then goes straight. This length this way is set up to create 3 wraps around the tube, and for the first 2 wraps it tapers in, and the last wrap it's straight. This portion right here will be the little piece of tubing that goes inside the winglet mount, and then this part here will be the triple layer thick ends of each piece of tube that fits in like this. I'm going to be using the same pultruded fiberglass tubing that I'm using as a mandrel as the fitting that goes inside the tube gets bonded in, that actually slips inside the next tube to join them together. And before this gets wet, I wanted to show you the pattern that's created when this is rolled up. Of course, when I wet this out, I'll be cutting away the masking tape. We don't want to bond that into the part, but I left the masking tape on so that you can see the pattern that's created with this particular setup. So as I roll the tube like this, we get a tapered portion on each side, and then we get a triple thick portion on the inside here. So that's how I can make a tapered wall thickness tubing that's optimized for strength just where it needs it and nowhere else. And having that tape on there helps everybody see how that's actually going to work out. Now this piece has to be centered on a 2-foot length of tubing. So if I trim this much off on here and the other end of the tube is here, the center of the tube is right about there. So this piece is going to be started off right here, like that, and then I'll have the other one down here. And this will make the 3 pieces of tubing that I need for the left and right wing. And we're going to go through that process right now. I'm going to begin to wet this out, and maybe we'll do a little medium fast forward so you can see the process go along. Okay, let's get the glue mixed up. This won't take much, maybe 120 grams, 150 grams of glue total. It's a 4-to-1 mix. I'll put in 100 grams here of basic resin. And then the 24 grams or so of hardener. I have to work fast today. It's very warm out. We're going to really taste the spring. I'm going to wet out the doublers first so that they can begin to set up slightly, and it allows me to use up the epoxy quickly. I don't want to leave a slug of epoxy sitting in the cup. It'll exotherm, and then I'm done working with it. If you're not highly experienced with a particular epoxy that you're using, I recommend something that has a much longer pot life. This has about a 10 or 15 minute pot life. It's very fast. I recommend something up around an hour. If you're using an oven to cure these parts, you don't need this fast cure epoxy anyway. You're going to pop it in the oven. It's going to be done in an hour. I'm going to do the same thing here. Okay, so there we go. We got that mixed up. And I'm going to pour out a little bit of resin here. That's probably way too much for that one. That's for sure. A little bit here. There we go. Now let's get our brush out. Let's do through the magic box here. And start spreading some resin around. Sometimes this resin will soak through the cloth and actually soften up the adhesive on the masking tape, and then I don't have to actually cut the masking tape away, I can just peel it off. And if I let these parts sit for a little while before I join them up, the resin will actually be not quite so runny, and the parts will be a little bit stiff. Not stiff, but they'll be gooey, much higher viscosity as they begin to set, and it will make them easier to handle. So get these all wetted out here. Generous amount of epoxy. What's going to happen here is the excess epoxy that's on this cloth is going to soak through, and it'll be left behind on the plastic sheet that I'm wetting it out on. So we don't have to worry about having too much extra resin. And then I can just begin to work the tube here with the brush, work over the cup. That way we don't waste too much of it. You wouldn't believe how much epoxy goes to waste. Here's an interesting little tidbit as we go through this process. The average composite aircraft, half of its weight is in adhesives. Laminating resin, bonding, epoxy, and so forth. So, given the cost of the resin, all the different epoxies, which is high, and the fact that they constitute half of the weight of the aircraft, we don't want to use any more than we absolutely have to build the part. And I'm always amazed at how much epoxy I throw away. I think out of every gallon and a half kit that I have, which is a quick $200 thereabouts, tax and everything, probably as much as 20% goes to waste. Left behind in cups. You know, oh, I got a little extra resin in the cup. Much better to mix small batches and add to it as you go along. In fact, I've overdone it here again. The 100 grams that I put out is too much. I'm going to have about, I think I'm going to have about 20 grams left over, so I probably used 15 to 20% too much resin to do this job. And we'll call that a lesson learned. Of course, not having made one of these before, I've made no samples of this part. I do not have a good feel yet for how much resin it takes to make these particular components, which of course is one of the reasons why I'm doing the video. Should some hardy soul in the future decide they want to build one of these for themselves, they'll watch the videos and they'll say, oh, I know not to use more than that amount of resin for that part. It'll save them some money and time. So here we are. I'm actually going to let these goo up some before we move on to laminating the doublers onto the tube. So I'm going to put my brush back here on the epoxy, take my gloves off. That epoxy is going to go in the freezer, and in the freezer it will keep for a good, hours. And then when I'm ready, I can bring it back out, warm it up. And these guys are nice and gooey. I can apply a little bit more of the runny resin and put the doublers on there. So we'll be back. Well, it's been about 15-20 minutes. This is gooed up nicely. It's about double the viscosity it was when I started, so it's good by me. We get the gloves back on here. Now, there's enough excess resin on here that I won't need to add any more of the stuff that I stuck in the freezer. It's going to work with what we have. It'll be plenty. So, let's see if we get the tape off the other side. Let's see if I can actually peel this stuff off. Might be able to, might not. Don't know for sure. We'll find out here in a minute. Get an edge. There's one. There goes one set. Get this off of here. Once the epoxy resin softens up the adhesive on the tape, it comes off fairly easy. Sometimes. Other times not. Okay, got lucky on that one. Okay, so now I need to find the spot that is centered. Let's see. I'll put the scissors here where center is. Let's see, I'm going to cut that about there. There's the center. So I can get this guy lined up. Get the skew out of it. They skew when you pick them up off the plastic. It's okay. So get this guy straightened out here. Whoop, whoop, whoop. Let's get them all squared up here. Oh, it's not too bad. Get that guy lined up a little bit. And start it on there. Get the edge up. Bring that edge up. It's a little gooey, sticks to the plastic. Just fiddle around with it. Just try not to fray the ends too much when you do this. It just makes it an extra big mess. And once you have it started like this, there we go. I can just kind of get things out of the way here and roll along. Make sure you got the edge tucked down all the way like this. You don't want any buckles in it. Then you can just lift them up. Once it's up, you can work this down by hand. Just like this. Keep towards the center. As soon as you start touching the edges, they're going to fray and unravel on you. So just work towards the center, just like I'm doing here. The ends will fray when you get down to the ends. Okay, just try to get the extra pieces out of the way. Try not to work it too much until you get the edge stuck down. Any extra long pieces like this, just take them off. Okay. Getting them off your hands, the tough part, huh? Okay, so I can now work this around like this. Make sure it's nice and tight all the way around like this. I'm going to fray a little. Now I can go out and work the edges here. Smooth those out all the way around. As you can see, I'm working in the direction of the wrap to do this so I don't lift up an edge. Get that end piece stuck down there. There we go. This part's a little tough right here at the end. If this wasn't, if I didn't allow this to set a little bit first, this part of the job would be much more difficult. It'd be much messier, there'd be all kinds of ends coming up. You don't want to do that. There we go, got the ends down. Now comes the tricky part. You have to do the other end without messing this one up. So we want to get on the peel ply as soon as we can so that some of the epoxy can work its way through. And ooh, we got quite a breeze pickup. I think I just had a little thermal go through. If I was out flying, I'd be turning hard right now. Okay, so I've cut the peel ply fairly narrow, a couple inches wide, and that's to accommodate the taper that's in the tube. I'm going to get this set up here if I can. There we go. I'm probably out of frame, but you can hear me anyway. I cut the, stay on there. Because the peel ply has to go over a tapered piece of tubing, it has to stretch on the bias a little, and that always works out much better if you have narrow strips of peel ply. And as I've mentioned in other videos, do not try to use the pre-cut peel ply that comes in narrow strips, because when they cut it, they use heat to cut it, and the heat seals the edge, which normally is a good thing, but in our case that's a bad thing, because then it prevents the peel ply from stretching on the bias, and it makes it very difficult to get over tapered portions of the tubing. So buy yourself a big roll of peel ply, cut off strips like I do. You'll be much happier. Okay, this little extra piece here, and we'll just lop that off with the scissors if they're not permanently glued. Pre-cut some gooey strips of shrink wrap here. That's fun. Woo, we're having fun now with the glue. This doesn't have to be applied with any particular neatness or anything. Any particular wrap will do because, you know what? It's going to shrink. So it doesn't really matter too much. I like to get it on there fairly flat. You don't have to pull it tight, once again, because, say it with me, it's going to shrink. I'm sure those of you out there who are going to replicate this process will be much neater and cleaner than I am. You're sitting there saying, why doesn't he do this and why doesn't he do that? And my answer always is, well, I just haven't thought of that yet. Can't think of everything at once. There we go. We got it all wrapped up in shrink wrap. I'm going to go hit this with a heat gun first. Very important that you hit it with the heat gun first. And then I'm going to pop it in the oven. I'm going to run it at about 150 to 180 degrees for about an hour. And then we'll be back to look at the finished tubing. Woohoo! We're back with the tubing. It's been in the oven about an hour, give or take. Doesn't matter too much. We're about halfway cured to start with. So I'm just going to open it up, see what we got here. We can just unspool the shrink wrap. Get rid of that. You look fine in the end in here. Somewhere in here. There it is. Take off the rest of that shrink wrap. Okay. Back down here with the peel ply. That'd be some fun here because the epoxy's come through and glued the tape down a little. Oh, that's not too bad. Let's see if we can find the end of the peel ply. In here somewhere. There it is. Oh, we can start to peel that off. Yeah, you gotta love that about these composite processes. There's a lot of single-use material. Drives up the cost. If you can find a way to use less material by reuse, more power to you. But this kind of the nature of the beast. You go through a lot of materials that you use once and throw away. A lot of vacuum bag material and sealant, tape and peel ply and leader layers and all that stuff. And that's part of what really drives the cost up. Disposables are not dirt cheap, but they probably add 20% to the cost of doing the project. Consumables. Now we got all of that off. We got a fairly good looking tube here. The big reveal. Here's where the doubler is, right here. And we see the ends are down nice and tight. We got nothing sticking up or no significant bumps. This one's a little bit better on this end, but they're both good. There's no wrinkles that I see at first pass. I'll have to do a little bit more cleanup work to get off all of this peel ply material. So now the big test, see if we get the tube off the mandrel. See how hard that might be. This is the first time I've tried this spiral wrapping of the release layer on a fiberglass mandrel. So anybody's guess as to how hard this might be to remove. And you're going to pretty much see it real time right here. Yeah, I feel some looseness here. And there she goes. Just like that. Bada boom, bada bing. Let's see if we can twist the plastic out of here. Now we're going to need pliers for that. Oh, there we go. We got this in and we twist the right direction and voila, out she comes. Wow, that works really easy. With the spiral twist, and when you twist the right direction, pulls it away from the wall, wraps it up really small, and zip out she comes. So that's much easier than the straight roll wrap, so I heartily recommend that you make your tubing. Now I can feel that this is not quite fully cured, so I'm not going to do any further work on it here. I'm just going to take it back inside, lay it flat on the bench, and we'll let this cure another few hours, and then I'm going to cut it into the sections that I need to create the 3 parts that I need for each joiner. I need that short, thick section here that goes in the winglet mount, and then I need a section here and a section here that bond into the D-tubes of each side of the wing. And when this is cured up and I cut it, I'll bring you back and we'll take a look at how it's all going to fit together. And I will be cutting this on my wet saw. I like using the wet saw diamond blade for cutting all the composites. It prevents delamination of them. But you can see that was a pretty quick and easy tube. In fact, this thing's so soft I'm probably just going to slide it right back on the mandrel. I'd say it's probably got another, I'm not going to put it back in the oven, but this is going to cure for another 3, 4, 5 hours before I cut it. There we go. That'll keep it straight while it goes through its final cure. But all the layers are tight together. It's just a little bit in the plastic stage, and it will firm up.